So we are going to continue with identity element. In binary operation, what do we mean by identity element? It's a very simple thing, okay? Now, an identity is when you combine an element, okay, with a number, and after carrying out the rule of combination, you get back your element. It simply means that what you have added or what you have combined with your element is an identity of your element. So let me use something to explain that. Let's say I have 1 and I add 1 to 0 and it gives me 1. What does that mean? It simply means that this thing that I have added to 0 does not really change the element or does not have any effect on the element. Therefore, we say that this one here is the what? Is the identity of our element. Okay? So let's have the two of them together. Let me have identity and inverse element. I like treating two of them together. Okay? Now, what is now inverse? Inverse is whatever that I will combine with my element and I will get the identity of that my element. Whatever that I have used to combine that and it gives me back my identity, it simply means that that element that I have used is what? An inverse element. Now let's write it in a way that it will be very clear for us. Let E be the identity element therefore A binary E, of course, which will give us E binary A equals to A. Okay, so you can just skip this one. What they are trying to say here, is that for an element to be an identity element, it must be commutative. Okay, it must be commutative. That does not mean that whenever you are asked to solve a problem on identity, you should not check whether they are commutative. Most of the time, all the identities are always what? Commutative. Okay, but that's the condition that it must be commutative to be an identity. So not just giving you back your element, but it have to also be what? Commutative. So you can see what is happening there. We have our element, we have our element. Okay, so whatever you have used to combine with the element and obey the rule of combination, that thing is called what? The identity element. Okay, it's called the identity element. And if A combine with a number I and it gives you E, okay, where E is the identity element of A, therefore I is the inverse element of A. Okay, so if you now combine another element with A and you now get the identity of A, that thing you have used to combine A with, obeying the rule of combination, is called the inverse element. So what does that mean? It simply means that you cannot solve the inverse element, okay, without knowing the identity of that element. Okay, you cannot find the inverse element without knowing the identity of that. So the first thing you do is to first of all get the identity element. Now you can now proceed to find the what? Inverse element. Now in some questions in the exams, they will ask you to find the inverse, okay? And they will not even say anything on identity. So what that examiner is trying to tell you is that you should first of all find your identity, then use it and get your inverse. Okay. So we are going to solve few questions here on identity and inverse. So we have our first example on identity and inverse elements. So that question says that if a binary operation is defined by x binary y equals to 2x plus y over 5. Find the identity element of identity element. Okay. So solution, we say let the identity element be E. Now we normally use E. That does not mean that E must be used. Okay. So you can actually use any alphabet of your choice. Remember, it's algebra, so just define your alphabet just like we have defined here. So anyway, I'm seeing E now, I'm going to see it as the identity element. You can use K, you can use P, any alphabet of your choice. Okay. So we have defined our E. Now we are trying to find the identity under this particular operation. So if I have x binary E, okay, what would that give me? That will give me back my what? X. Okay, it will give me back my X. So if it's going to give me back my S, obey the rule of combination and equate it back to S and find the value of your E. That becomes your identity. So that will give you 2 S plus E over Y equals to over 5, sorry, over 5 equals to X, okay? So here you cross and multiply, you have 2E, 2X plus E equals to 5S. So this one move over here, you have that E equals to 5S minus 2S, so E equals to 3S. So you can see that E equals to 3S, it becomes our identity. So when you combine X and 3S, you are definitely going to get back your X as your answer. So that's how to find your identity. It's very simple. So let's look at other examples. So we have our example 2. It says that given a binary operation, x binary y equals to x plus y plus 2xy. Find the inverse element. Remember what I said. Okay, remember what I said, that you cannot find the inverse element until you know the identity element, because you need the identity element to find the inverse element. Okay, so let's partition this board into more portions. So we define our identity, so let E be the identity element. So E is our identity element. Therefore, if we combine X obeying the rule of combination of the binary operation, we'll get back our S. That's what makes it an identity. So let us combine that. That will give us X plus E plus 2XE will give you back X. Okay. So when you solve that, you have that E plus 2SE equals to X minus X. So factor E out here, 1 plus 2X equals to 0. So E equals to 0 over 1 plus 2X. Okay, that's when you divide both sides by 1 plus 2X, and therefore E equals to 0. 0 divided by anything will give you back your 0. So we have gotten our identity. So the next thing now is to go ahead and solve for inverse. But remember, the same way we have defined E to be the identity, we also need to define our inverse. So let I be the inverse element. Okay, let I be the inverse element. So with that now, we say therefore X binary I will give you E. Already we know our E. So that will give us x plus I plus 2xi equals to e is what? 0. So with that now, we can solve for I. That will give us that I plus 2xi equals to this crossover I have minus x. So factor your I out. So 1 plus 2x equals to minus x. Divide both sides by 1 plus 2x. That will give you that I equals to minus s over 1 plus 2s. So this become our inverse element. This is the inverse element. This is the identity. Okay, so let's look at more examples on this and see if there will be any difference from what we have been solving. So if you look at the third example, they have given us our rule of combination for A and B are in numbers. They now say that if the identity is 0, find the inverse of 2. So we have been given identity already. Okay, so you have your solution. What does that mean? We are looking for the inverse of 2. So if we have 2 binary, our inverse, it will give us 0, which is the identity. We have done this in the previous examples. When you combine an element with the inverse, you get the identity. So from the question here, you are looking for inverse of 2. So 2 binary, the inverse, will give you the identity. So that will give you, obeying the rule of combination here, you have 2i plus 2 plus I equals to 0. Okay, so I have obeyed the rule of combination to expand that binary operation there. So collect like terms, we have 2i and I. That will give us 3i equal to minus 2. That's when this one move over here. So divide both sides by 3, I equals to minus 2 over 3. Therefore, minus 2 over 3 is the inverse of inverse element of 2 under the operation. So under that particular operation, minus 2 over 3 is the inverse of 2. Okay, so let's look at the last example on this particular topic. Okay, so we have an operation there and we are asked to find the identity element. So it's similar with this number 4. So it's similar with a question we have solved, I think number 2 or so. So all we need to do is to have our solution and let E be the identity. Okay, so if E is the identity, therefore M binary E will give us what? Will give us back our M. Okay, so solving that, we have that ME plus E plus M equals to M. So collect like terms, E into E, M minus 1 equals to M minus M. So E into M plus 1 equals to 0. Divide both sides by M plus 1. We have that E equals to 0 over M plus 1. Therefore, E equal to what? 0. So you can conclude 0 is the identity element under the operation. Okay, so this is where we are going to conclude this topic. So probably our next topic might be modular arithmetic. So I'm looking at, because there's a connection between modular arithmetic and binary operation. Also, there's a connection between set and binary operation. So one of these topics will be coming your way next. Okay, please, if you're here to subscribe to this channel, subscribe it and share our videos. And do not forget to give us a thumbs up so that the video can be able to reach out to others. Okay. Thank you so much for your time and see you in the next class.